How many of you have had a family member that's been affected by cancer? Wow, see, that's a lot of people. And that's not a surprise. In the US alone, about 1 in 2 men or 1 in 3 women will have cancer in their lifetimes. I myself had a very close friend, my college roommate, had passed away of cancer. And just today alone for the US, there's going to be more than 1,500 US Americans who are going to be passed away from cancer. This is a big problem. It doesn't matter whether you're young, it doesn't matter whether you're old. Cancer is there to cause a big problem for all of us. So today I'm going to talk about, is there hope for cancer? Is there things that are on the horizon? Are there things that we can do? We're going to take a rapid tour looking at some of the most exciting developments in cancer, starting from the beginning and looking into the future. We're going to go to 4 different categories. We're going to be looking at diagnosis, we're looking at the people, we're looking at the location, and we're looking at therapies. Firstly, let's start with diagnosis. How do we diagnose cancer? For most people, you spend most of your time at home, right? And what are the tools do you have to diagnose cancer? There really isn't much. You have your scale to measure your weight. You have a mirror to look at yourself. And maybe you're able to sort of have your hand to be able to do exams. But that's it. We have very little tools currently at home to be able for us to detect cancer early. Some people may have other tools at home for medical, be able to sort of measure whether your blood glucose, whether your blood pressure, but these are really not very effective in terms of determining whether someone will have cancer or not. So then unfortunately, the way that most people are able to present with cancer is through sickness. There are mechanisms for us to have screening, such as colonoscopies, for mammograms, but these are sort of low resolution, and often by the time the cancer is caught, it's often too late. And even within a hospital, there's very high tech, there's a lot of imaging mechanisms, whether it's CT, MRI, all these ways, but still, why are we sort of catching cancer too late? We do all these screening, but the key is, how are we able to detect cancer early? How are we able to detect it before it grows so large that we can't treat it with surgery or other therapies that we have? In 2001, one of the biggest breakthroughs in human biology was the sequencing of the human genome. We were able to map the DNA for the first time. And a group of us at Johns Hopkins were able to map actually the genome of cancer for the first time, finding biomarkers in breast cancer, colorectal cancer, pancreatic cancer, and brain cancers. And with this now, efforts around the whole globe are now looking at markers in the DNA for cancer, for us to be able to detect cancer earlier. And machines now that used to be able to, cancer used to take billions of dollars to be able to sequence a genome. Now we can sequence in terms of weeks or even days. And some of these machines are even fitting on our desktop. And the price drop has been almost a millionfold. So imagine, what can $1 million buy? It can buy you not only 1, but 2 Ferraris and 2 Lamborghinis, and now we can do that for $1. And that's the drop that we're able to do in cancer genome sequencing. And then they've shrunk down in size, and soon we will have drives be able to sequence similar to like USB drives. And this is all coming, and this is very exciting. So is it happening? Is it affecting change? At Washington University St. Louis, where I was faculty, we established such a program, and there was a woman with thymus cancer that came to us. We sequenced her genome, and actually, she ran out of drugs for her cancer, and we were able to use a drug from another cancer because of her genes to then be able to treat her. 2 years later, she is still with us today. And there has been studies. This is actually just this week. 14 centers across the US have been doing this type of genetic screening for lung cancer. And they've found that genetic screening has been able to extend lives. And for us now be able to really target and be able to be specific in the type of drug that we're able to give patients and really personalize their therapy. And not only on the DNA level, we can also look at the mRNA, the genes that are expressed. And that has been able to, we're able to measure that millions at a time, which is really amazing development in science. And there's a cool story, for example, at Washington University St. Louis, where I was faculty. This is Dr. Wortman, who himself, cancer researcher, but himself got leukemia. His genome was sequenced. We were able to, his DNA was mapped as well as his RNA, and they were able to find actually, instead of leukemia, a kidney drug that was able to use for him and be able to put his cancer back into remission. So we're now thinking of cancer not only as organs, but as gene-based, and this is completely changing how scientists and physicians will think of cancer in the future in the realm of cancer genomics. Even more, we can think of proteins. This is a little bit further up. And on a single microscope slide, they can measure tens of thousands of proteins at the same time. With my collaborators at Johns Hopkins, we're now working on ways to look for biomarkers on a proteomic scale. And there's large machines that are able to measure hundreds, if not tens and hundreds of thousands of proteins all at the same time in hope of finding that specific protein that you can give the drug for. And there are companies now that are able to really tailor what proteins are able to be found so you can give the right drug for the right protein. And even more, we can start detecting stuff just in the blood without actually having in the tumor. So companies are now able to detect tumor circulating in the blood. And even more, they're able to use this whole lab on a chip. They can take single cells and be able to determine and catch cancer early. And not only cancer cells, but also DNA. They're able to look at floating DNA cells. In my old lab at Johns Hopkins, they just reported a survey of over thousands of patients for them to be able to detect floating cancer DNA in the body. They can't even find cells yet, and they're able to detect this early. And this is now going to change entirely how we think about cancer therapy. And there's hundreds of companies now working on this to be able to have early diagnosis for cancers. And really the hope is for us to start diagnosing cancers while we are still healthy before it's too late. So cancer needs people to be able to sort of, in terms of healthcare workers, to be able to diagnose and help treat them. And we have this picture of sort of old physicians being able, and this picture really is similar to the way hospitals are these days. It could be a little bit different, a little bit fancier material, but it's the same, with great support staff. But now physicians are now being able to be advanced in terms of what they're able to do. So it's more than just sort of a computer. You can look on the internet. It's more than that. It's more than just sort of having your records on the internet, right, which is just a replication of what's already there on paper. And it's more than just collaboration and getting whole groups. What it is able to access all that information, all the papers that are published, the hundreds of thousands of papers that are published in cancer, the hundreds of thousands of records, all together that a human mind actually is unable to process. So there are some early efforts to be able to organize this information, as well as clinical decision tools. But what's cool is companies like IBM were able to take Watson, which famous for beating Jeopardy, now being trained to go to medical school and become an oncologist and assess all that information and help oncologists to be able to best treat with the best literature, with the best records, in a way that humans aren't able to do. And the Mayo Clinic, for example, is using big data to monitor the ICUs and be able to look using one glance and using metrics in a very similar way. And doctors now, there's some discussion about Google Glass. Ohio State recently just had a surgery where they sort of telecast on Google Glass. But that's just telecasting. Can you make it even better? At WashU, they've been able to inject the dye into patients and with special glasses and are able to see on the screen, that's where the cancer is, bright and clear, and you don't have to sort of go back for that. And the options and the possibilities are endless. Robotics, which is now currently very much available in the vision systems, but there are now open source systems. And this screen capture from the Ender's Game, this is a system called the Raven system for robotics. Now surgeons can be equipped with mechanisms that be more precise than they can ever before. And Minority Report will be, wow, that's nothing for future physicians, because they're going to have more than what Tom Cruise has access to. Next is location. Where is cure going to be? This is from 50 years ago, computers, one computer, and now this is a computer on your phone. But this is a hospital from 50 years ago, and this is hospital today. There's not much that different. How can we think about sort of shifting the care into homes? There's some discussion about telehealth, and companies like Cisco and Intel have been doing sort of a lot of efforts there. And there's some sensors, whether it's sensing steps, whether it's sensing your EKG, whether it's sensing your glucose, whether doing eye exam, whether it's doing an EEG, whether it's doing it's an ultrasound, or whether you're doing your vitals or continuous vital monitoring. All this can be done at your home at a very, very low cost. So low that even overseas that they can do eye exams with just a cell phone. And my friend Michigan, he's doing urine exams that's on strips that being able to test it on cell phones. So now the possibilities are endless. And the future, I don't think it's going to be like the movie Elysium. This actually is a monstrosity in the home. I think the future of medicine at the home looks like this. You don't see anything. It's just there, right? Maybe it's something in your toilet that is able to collect your stool and be able to detect mutant DNA. Maybe it's in your mirror while you shave, you bleed a little bit. Oh, they can do a blood test right away. The possibilities are endless there. And lastly, we're going to talk about how can we be able to cure for cancer. Old methods are very crude, right? Surgery, which is still very much the same with a little bit better technology. Chemotherapy is very toxic, as many of you know, derived from, one of them from mustard gas. Radiation is you can localize it, but it's dangerous as well. How can we figure out ways that are much more targeted? So with inventions like drug like Gleevec and many others, there's now targeted therapies that attack just the tumor and not the normal people. And there's even efforts to be able to custom print drugs. This is at University of Glasgow. And whole new modalities of drugs are now available, not just chemicals. These are monoclonal antibodies. These are viruses that are trained to be able to attack cancer. And these are now in clinical trial. And the first one was available in China and now in the US as well as bacteria now be able to use as a whole new modality, and your own T cells be able to train and re-engineer to be able to attack cancer, named the scientific breakthrough of last year. And we can use tools like mice and fly and be able to train them so they have our exact DNA makeup so that we can test drugs for them, or make our own cells and grow artificial lung on a chip, or we can get a whole body on a chip. And this is all the present reality. And if you're missing a bladder, let's just grow one, because if you're bladder cancer, if you're missing bone, we grow a bone. Or you're missing organs, and this is now starting, companies like Organ Novo or Epibone, this is now definitely a reality. And we are now thinking of using nanobots, work out of Harvard, where they have DNA origami and be able to have a payload with the right signal and opens up and delivers the drug. And the dream is to have a magical cocktail that you drink, composed of viruses, bacteria, and nanobots, and small molecules, all tailored to you, that you drink it, it sort of kills all the cancer, and then you're done. And that's the hope. Our previous generations were able to eradicate diseases like polio or make HIV one of a chronic disease. The hope for this generation is that we are now starting to see an amazing revolution in cancer, and it is now a possibility to make cancer a chronic disease and no longer a Scrooge. This is possible, and we can all work for this future. Thank you very much.